This is Math Studies Lesson 4.2, and in this lesson we're going to talk about slope. Slope is a topic that you've hopefully had a lot of experience in. It's discussed in Algebra 1 and in Algebra 2, but basically it is the rate of change more specifically the change in y over the change in x. And we write that y2 minus y1, that's how much y changes. x2 minus x1, that's how much x changes. Maybe you've heard it called rise over run. And slope basically tells you how fast something changes, rate of change. A positive slope on your axes will be anything that is an upward pointing line. A negative slope would have a downward pointing line. Examples of a positive slope could be 3 or 4/3 or even 0.1. Those are all positive slopes. Negative slopes would be the same thing, but -2, -5/8, -0.6, those are all negative slopes. A zero slope on your axes would go horizontally, and an undefined slope would go vertically. If you've ever heard of the vertical line test, this one is undefined. It fails the vertical line test because a vertical line drawn through this line would hit infinitely many points. But a zero slope could just be 0. It could be 0 over 6, really 0 over any number. Because when we divided those, they would be 0. An undefined slope would be 5 over 0. It's changing 5 vertically, but it's not changing horizontally. And that's why it's undefined, because we cannot divide by 0. Okay, scrolling down. Parallel and perpendicular slopes. So two lines are parallel if they do not intersect, and on a coordinate grid that would happen when they have the same slope. So obviously 5 is parallel to 5. The slope of 5 would be parallel to the slope of 5 because they're the same number. But it doesn't have to be so obvious. We could say 1/2 for a slope, and that would be parallel to 0.5 because they are the same number even though they're in different forms. And another example might be 4/3 would be parallel to 8/6. If we reduced those, they would be the same number. Perpendicular on the coordinate plane is when we have a line and another line crossing that first line at exactly a 90-degree or right angle. These slopes are negative reciprocals. And so an example of that would be 5 is perpendicular to -1/5. So the sign changes from positive to negative, and then the reciprocal means you take that value, that rational number, and you flip it over. So 5 is really 5 over 1, so I flip it to 1/5. Another example might be -4/3 is perpendicular to positive 3/4. So in Fraction form, it's really obvious. We take the fraction, we change signs, and we make it negative. A decimal, how about 0.5? That's easy. 0.5. If we reciprocate, is that a word, reciprocate that? It would be -2, make it negative, because 0.5 is really 1/2, and when I flip 1/2, it becomes 2/1, which reduces to 2. So those are examples of perpendicular slopes. Scrolling down for the examples. Match the slope with the line. So I have a slope of 5, a slope of 0, a slope of 4/5, and an undefined slope. So A and C, I start with A. A is looking for a positive slope. Only one of these lines has a positive slope, and that would be letter C, because this is an upward pointing line. B matches with a 0 slope, and a 0 slope we said was a horizontal line, so letter D. C matches with a negative slope. The only negative slope we have is letter B. And the undefined slope would be the vertical line. Vertical lines are undefined, so that matches with A. More examples on the next page. Find the slope between the points -2, 1 and 7, 3. So we're going to label these just like we did with the distance formula. Ordered pairs are x, y, and the first point will get 1s. X, y, and the second points will get 2s. The slope formula was written at the top of the page before. y2 minus y1 on top, x2 minus x1 on bottom. Remember, minus and negative is the same as plus. So that is 2/9, and if we wanted the decimal, that is 0.2 repeating. Letter C says draw lines through the point 2, 3 with slopes 1, -3, 0, and 2/3. This is going to be kind of a crowded exercise, but 2 over and 3 up tells me that every one of my lines is going through that point. A slope of 1 is means we're going to go up 1 over 1. Every time it's a whole number, you can always put it over 1 to show you the rise and the run. So rise 1, run 1, rise 1, run 1. And I can do the same going backwards just to kind of see where the line goes. So this is that first one. A slope of -3. We're still going through the same point. I'm going to make it over 1, so I have a rise and a run. If I rise -3, it means go down 3 and then run 1. Down 3 and then run 1. That's kind of off the graph, but I can eyeball it. And I'll go backwards so I can see that next line is right here. A slope of 0, remember, is a horizontal line. I can add the over 1 if I want to, but over 0, or up 0, because rise over 1, up 0 over 1, up 0 over 1, up 0 over 1. This is the horizontal line. And then the last one here in black, 2/3, starting at that same point, rise 2, run 3. I'm going to go backwards, 2, 3. And so here is that last one. Final example, letter D says a line has slope of -4. What slope is parallel to the given line? Two lines are parallel if they have the same slope, so parallel, just same exact answer, -4. What slope is perpendicular to the negative line? We need to change signs, so it'll be a positive number, and then we reciprocate it, meaning we make it a fraction and flip it over. So we could say positive 1/4, or we could give the decimal answer 0.25. Okay, that was a long bunch of notes, so hopefully you were able to follow all that. Good luck with the exercises, and please let me know if you have any questions.